How is climate change impacting the chemistry of the northern Gulf of Mexico? What are the impacts of eutrophication in addition to the chemistry of the northern Gulf of Mexico? Hello friends, Jim here. Well, this is a interesting paper showing the impacts of climate change affecting a significant region of an important area, the northern Gulf of Mexico. It was a paper that came out earlier this year in March of 2024. And Zhongpei Zhang is the lead author and the lead PI, and there's a whole bunch of colleagues involved in the paper. As usual, I will leave the URL link in the description as well as in the comments. Let's take a look at the abstract. Coastal waters often experience enhanced ocean acidification due to the combined effects of climate change and regional biological and anthropogenic activities. Through reconstructing summertime bottom pH in the northern Gulf of Mexico from 1986 to 2019, we demonstrated that eutrophication-fueled respiration-dominated bottom pH changes on intra-seasonal and interannual timescales, resulting in recurring acidification coinciding with hypoxia. Highlight that there. Basically, eutrophication is, in essence, an overload of nutrients. And when you have an overload of nutrients, yeah, it's great for the primary producers, but then you end up tanking the biological oxygen demand so that oxygen gets depleted from the water, and that then leads to increased mortality. And because you get hypoxic zone, in some severe situations, anoxic zones. So that's kind of what they're alluding to here. Basically, the overload of nutrients coming down basically the Mississippi and another river we'll mention later on. However, the multi-decadal acidification trend was principally driven by rising atmospheric CO2 and ocean warming. Right? Get more CO2 in the waters, combines with water to form carbonic acid, which lowers the pH, which is increasing the acidity. With more acidified and less buffered hypoxic waters exhibiting a higher rate of pH decline, minus 0.0023 per year in pH, compared to non-hypoxic waters, which is minus 0.0014 per year. The cumulative effect of climate-driven decrease in pH baseline is projected to become more significant over time, while the potential eutrophication-induced seasonal exacerbation of acidification may lessen with decreasing oxygen availability resulting from ocean warming. Okay, so what they're basically saying is absorption of atmospheric CO2 along with the ocean's warming leads to increasing acidification. Eutrophication, nutrient overload, works synergistically to make the decrease in pH worse for both hypoxic and non-hypoxic waters, but more so for hypoxic waters. That's kind of what they're getting at here. And of course, oxygen solubility decreases as water warms up. Mitigating coastal acidification requires both global reduction of CO2 emissions and regional management of riverine nutrient loads. Okay, so what are the key points? Okay, they reconstructed summertime bottom acidification history from 86 to 2019 in the northern Gulf of Mexico, predicted future trends towards 2100. Rising atmospheric CO2, ocean warming, drive decadal decline in pH baseline, while eutrophication exacerbates summer acidification. Less buffered hypoxic bottom waters showed a higher decadal acidification rate, the aforementioned minus 0.0023 per year, versus non-hypoxic waters minus 0.0014 per year. Less buffered. We'll explain what that means later on. But if the waters are less buffered, there's less ability to neutralize carbonate ions, right? Then the acidity is going to increase. Your pH will go down. Northern Gulf of Mexico is an ecologically and economically vital coastal system facing acidification threats from both climate change and eutrophication. The first robust multi-decadal pH reconstruction from 86 to 2019 revealed recurring summer bottom acidification in the Gulf's oxygen-depleted, quote-unquote, dead zone. The seasonal acidification and year-to-year differences were driven predominantly by respiration intensified by eutrophication. Don't forget, all the excess nutrients, on paper sounds great for the phytoplankton. Right? Hey, phytoplankton is going to go to town producing. You would think that would help the secondary, consumers, or the primary secondary producers, the primary consumers. But don't forget, the producers themselves, the primary producers, they also respire. They use up the oxygen. However, over a multi-decadal timescale, rising atmospheric CO2, ocean warming emerged as the dominant acidification drivers. More severe acidification occurred in the dead zone each summer, and these waters were acidifying more rapidly over decades. Looking ahead, climate-driven pH decline is projected to become more pronounced over time, while potential eutrophication impacts may lessen as warming reduces oxygen availability. Mitigating acidification requires global actions to curb CO2 emissions, etc., and managing the nutrient introductions. If you wish to learn more of this topic that was discussed today, please support my work. You can do so by joining my YouTube community, become a patron at Patreon, or buy me a coffee. You'll see the details on the screen as well as in the description box. There I will do a deep dive video providing my analyses of the various figures as well as explanations of the concepts and their importance to the research that is featured. Thank you.